Alright, so next I am going to go through this circuit simulation, and I'm going to measure the voltage and current across each resistor. So this is the third video that I've made here, so I strongly suggest, if you haven't watched the other videos, please go take a look so you can understand what's going on with LT-Spice and what exactly I'm doing. Alright, so first things first, let's get our VR1. So again, I'm just going to drag our nose across like that and throw a cursor on. So VR1 is 2.442 volts. Let's see if I can blow this up. I can't make this any bigger, so unfortunately that is as big as that gets. I apologize if that's kind of hard to read. But our VR1 is 2.442 volts. Okay. Let's get rid of this guy. Next we want VR2. So R2 is connected directly to ground, so we can just measure this node with respect to ground. And it looks like 2.558 volts. Alright, so please make sure you are noting all of these values down, and make sure that you note that these are coming from LT-Spice, not the actual circuit, and not your own calculations. Okay? Next up we have VR3. So this is going to be 124.02 millivolts. Okay, 124.02 millivolts. You don't need to worry about the horizontal because this is a DC circuit. This is going to be a constant voltage through at any given time. Okay, so 124.02802 millivolts there for VR3. Now we can get VR4 and VR5 all at once because they are in parallel. We know they'll have the same voltage drop. We can just grab that, and that is going to be 2.432 volts. Okay. Just find a reasonable place to estimate that. You don't need to write out all of these decimal points. That's a lot. So VR4 and VR5 are 2.432 volts. Let's check out VR6. VR6 is 19.865 millivolts. Okay. Just make sure you're getting all of these down. Hopefully they're looking pretty similar to the values you calculated. VR7 here. VR7 we've got 2.113 volts. Okay. Alright, 2.113 volts there, and the last one is VR8. VR8 is going to be 422.66 millivolts. Okay, so make sure you note that 422.66 millivolts for VR8 there. Awesome. So those are all of our voltages. Now you should have calculated, I believe, 2 voltages here, so make sure you compare those two. So see how those two compare, the voltages that you calculated versus the ones that I just measured in simulation, and throw out some ideas as to why they may be different. Alright, if they are different, that is. Now, let's look at current. So, interesting thing that I have noted is these current sources, they're always backwards. So these are always going to give us negative values. So, I'm just going to flip it to positive because we're going to assume current is flowing this way, right, in this direction. I don't think there's an easy way to tell LT-Spice to consider the current as going in that direction. So, here we are. First thing we want to look at is the current coming out of our voltage source. So it's looking like our voltage source is supplying 2.444 milliamps. Okay, you got 2.444 milliamps coming from here. Alright, I'm sorry. Gosh, you can't really see that trace there. It's in blue. It's hard to see. But IR1 here is also going to be 2.444 milliamps. That makes sense, right? Because this is in series with our voltage source. Right? Okay. Next, we've got IR2. That looks like it is 1.162 milliamps. 162 milliamps there for IR2. IR3 is 1.24 milliamps. Okay. Also, I should note the way I'm just quickly switching measurements is actually if you double click on any component, it will only show that measurement on the screen, on our chart. And so that lets us really quickly switch between measurements. Okay, so IR3, once again, 1.24 milliamps. IR4, we have 24.32 microamps. So very few amps there. So 24.32 microamps, very low number. IR5, we have 1.216 milliamps. 216. Now IR6, IR7, and IR8, these are all going to be equal, right? Because they're in series. So we can just take one of these measurements, and we will assume they're all the same. And so for this branch, it looks like IR6 is 42.266 microamps. Okay, 42.266. And in case you don't believe me, I can do the same thing for IR7 and IR8. They all have identical values. They're all 42.266 microamps. All right, great. So those are all the values you're going to need from this simulation for this circuit. So then, referring back to here, please comment on if this simulation agrees with your hand calculations and hypothesize why or why not. Show that the calculated equivalent resistance makes sense using the voltage and current from this circuit. Comment on why an equivalent resistance is useful for this circuit. Right, so we measured the voltage, or we measured the current coming out of our voltage source, and we know it's 5 volts. So just use that and Ohm's law to get an equivalent resistance and talk about why that's useful for this circuit. And of course, compare to your hand calculations. And then anything else you find interesting about this part here. Alright, great. So that is all for this part of the circuit simulation. Thanks.